Let's talk about the Fender Blues Jr. for a minute. Let me just start out by saying, as a professional musician and someone who repairs guitars and amps for a living, I think the Blues Jr. circuit at its core is a great circuit. It can be a fantastic sounding little amplifier. I just think that in my experience, having been somebody who's owned one and played one for a while, the configuration that the amp comes in from the factory doesn't do the circuit or the tone any real kind of justice. It's a small amp with, in my opinion, a cabinet size that is way undersized for putting a 12-inch speaker in it. It just tends to have a particularly boxy kind of tone to it. And that's not to say that you can't get around that, or that I haven't heard guys playing these live and they didn't sound any good. Like I said, they can be made to sound good, or even great for that matter. But depending on the situation of where you're playing, be it live or in the studio or what have you, it may take some tricks to get it to really sound impressive, such as using it as a head with extension cabinets and things like that. So I just wanted to preface this video by saying that, because I know there are many players out there who love these little amps and swear by them. And for that reason, I don't want to make anybody mad by the following things that I'm going to be saying in this video, because I'm going to be talking a lot about the downsides to this amp and why I would consider recommending choosing a different amp if you're looking for something of a similar profile or similar size and output rating or volume. So all that being said, I'm going to use this amp that came in for repairs as my case in point for this video. So just a quick backstory. This amp first came to me several years ago. This amp was, or at least had been, the owner's main gigging amp, who is a professional gigging guitarist here in the local Fort Worth music scene. And he really liked the amp, but he felt that he could really get more out of it if he changed up the configuration. So he had ordered a custom-made 2x10 cabinet from eBay, I believe, and he wanted me to pull the chassis out of the amp and fit it into this custom cabinet, which he could take with him as a combo. So that's what we did, and we outfitted it with a pair of WGS speakers, the G10C and the ET65. And that, in and of itself, just really opened up the amp. It made it sound much fuller, much less boxy, and much easier to get really great gigging and recording tones out of. So after all that, the owner was much happier with the sound and the tone, and I believe he continued to gig with it for a couple years until he went and fired it up at a gig, and he told me it made a really ugly sound and thinks he saw a flash from the tubes, and then it quit and blew a fuse. Popped a new fuse in, and it did it again, and that's when he brought it back to me. So I just wanted to quickly give the backstory about it, because it'll explain why I decided to do what I did a little bit better. See, normally speaking, if someone was to bring me in a stock Blues Jr. that had the same issue and the same failure, I would probably end up telling them that in order to make it more reliable and do the repairs necessary to get it to where it's not going to come back in 6 months or sooner, that the bench fee for the repair would very likely exceed the resale value of the amp. And that really all is the biggest issue I have with these amps, is that, at least from what I've seen with these, it's really a matter of time before they end up having significant failures to them. And in my opinion, that's largely due to a lot of pretty poor choices in the design and layout of the chassis and the components. And really the way it's designed and built and manufactured in stock form, in my opinion, doesn't allow the amp to really shine as much as it could. And so given the fact that we had already done a lot of work to this amp, and also due to the fact that the owner has become a good friend and has been a longtime client of mine, I felt that this particular unit was worth all of the time and effort and cost that was spent to getting it back to its full glory and more. So anyway, I apologize for the 5 minutes of yapping at the beginning of this video, but I really feel like the backstory and sharing some of my thoughts and opinions would be valuable to a lot of people that might be watching this video. So forgive me for that, but let's get into what I did with this thing. So given that the client told me that he had already tried replacing the fuse and firing it up and it still continued to blow fuses, I knew that we had a pretty significant internal issue. So I went ahead and just opened it up, and didn't take me long to see something pretty obvious. And that's what we're looking at here. This is the Blues Jr.'s tube socket PCB. So this here would really probably be my number one issue with the way these amps are designed and built. This right here is how the through-hole PCB mounted tube sockets are installed on the board. There are two main issues combined that I see with these amps that lead to this type of failure. Number one is that the tube sockets being mounted into the PCB like you see here, there's nothing to stabilize them. And so really the only thing holding the tube socket into the board is the solder joints at the points where the traces meet. And the other issue is that these amps typically come out of the factory biased very hot, way over biased. And what happens in this little dual EL84 amp is the tubes run so hot that it's just a matter of time before they start cooking the board. As you can see, there's clear signs of discoloration on the board from all the heat. So what happens is the flimsy installation of the tube sockets combined with the excessive heat that comes up off the tubes over time can do a number of things. Number one, the heat can cause solder joints to become compromised. And because of the fact that there's no added stability other than the through-hole mounting for the tube sockets, the excessive heat can actually start to compromise the pads and the traces that the tube sockets are actually soldered to. So what happens is the solder joints begin to fail, which are the very things that are holding the tube socket in place. So as the traces start to become damaged from the excessive heat, the trace pads that the tube sockets are soldered to can start to lift up. And what happens is the more they lift up and become loose, the more likely they are to become damaged or broken. And that's when arcing can happen, which will further damage not only the PCB and cause burns and all that kind of stuff, but it can lead to other issues down the line in the circuit. And this is what I'm talking about here. This is underneath the main board. When I pulled it up and disconnected it, you can see here carbon traces or obvious signs of burning. And this is where the ribbon cables that come off of the tube socket board connect into the main board. So upon discovering all this, it was at this point that I had to make some decisions about how to proceed. Yes, I could have made do with what I had to work with and made the repairs, and I could have gotten this amp working in its stock form. And when it came to the tube socket board, I could have tried to repair traces or installed jumper wires and all that stuff. But all of that really doesn't solve the issue. It solves the symptoms. And I was not confident that even if I made those repairs, that the amp would still be stable and reliable and not continue to want to catch up on fire at a gig. You can actually purchase replacement tube socket boards, I imagine for this very reason, because it's a high rate of failure in these amps. So mainly due to the fact that the owner is a good buddy of mine, and I'm always a sucker for a good challenge, and I wanted to be confident that when this amp came out of my shop, it was going to be reliable, it was going to sound good, it was going to be trustworthy to take to a gig and not worry that it was going to blow up or catch on fire, and that it would be an amp that would serve the client's needs for many years to come on stage and in the studio. So to summarize my biggest issue with these amps in a nutshell at this point is that really there are parts and components in this stock form amplifier that generate too much heat for the construction to adequately accommodate. And I very well know, as I see in many forums and discussions, that there will probably be people that show up to the comments and say, well, I've been playing on my Blues Jr. for years and it's always done just fine for me. I've never had any issues with it. And that's great. I'm glad you haven't had issues with it. And I hope you never do. But I'm just speaking in terms of somebody who ends up having to get in these things on a regular basis to solve problems. And the problems that they have, I see over and over again. So if you haven't had any problems with yours, great. You're very lucky. But that also doesn't mean that the problems that this amp had are not lurking in your own, and they're just waiting for the next gig or the next opportunity for them to finally give up the ghost. That's all I'm saying, is just know what you have, and if it's still working and hasn't given you any problems, that's fantastic, and I'm glad. And maybe you take care of it or treat it a little bit better than most, but suffice to say that there are actual objective reasons why these things have very high failure rates. Anyway, it was at this point that I had the decision to make. Do I go all in and completely rebuild this thing in a way that I am satisfied will be reliable and stable and won't want to catch on fire and will be easily serviceable in the future? Or do I just get it working and hope for the best? Well, again, for the reasons that I mentioned previously, I decided that this amp would be best served, and the client for that matter too, if I just decided to completely gut the thing and rebuild it from scratch. So that's what I did. So moving on to tackle the first and biggest issue was trying to figure out what I was going to do in terms of getting any kind of a reliable, stable tube socket board. So when I say I decided to go all in, I really went all in, and that meant that the only way I was truly going to be satisfied with the build quality of this amp was to rebuild it all in hand-wired construction for stability, reliability, and ease of service or modifications in the future. Now, as I said before, in my opinion, the tube socket board was so far gone that it didn't seem practical or wise to even try to repair it. Also, I knew I didn't want to have to fool with PCB mount tube sockets. I wanted to be able to fit this thing with real good quality solder terminal tube sockets. And those were going to be chassis mounted. So I had to figure out a way to get those onto the board and still make it work with the original chassis. Now, as I mentioned a moment ago, you can actually order replacement tube socket boards for these things. But given that I was trying to keep this whole project as budget friendly as possible, I decided to see if I could repurpose the original tube socket board and modify it to make it work with the construction that I had in mind. So step one was to take the original tube socket board and see if I could modify it so that it would accept good quality chassis mount tube sockets that I could hand wire the connections to. So after desoldering and disconnecting all the tube sockets and ribbon cables and everything, I removed the board for the tube sockets and drilled out the holes to the right diameter so that I could mount the chassis mount tube sockets to the board. Once I test fitted and verified that it would actually work, I then prepared the board by sanding all the copper traces off of it, the front of it, and then spraying it with several coats of high temperature heat resistant paint. Next, I test fitted the tube sockets and made sure that they were oriented in the correct position. The first two starting from the right are the first two preamp tubes. The middle one is the phase inverter, and the last two are for the EL84 power tubes. Next, I made and fitted the wiring for the tube heaters. At this point, I decided I was going to fully commit to this hand-wired rebuild conversion. So using the schematic for the Blues Jr, I began to draw up and create a layout as a template for laying out the components on the board that I was going to make. I was actually able to find a suitable sheet of fiberglass epoxy board on Amazon. Then, of course, I did have to cut the fiberglass board down to size after I made the template for the layout. And after trying a couple different methods, I ended up putting a metal cutoff blade in my table saw, which actually worked pretty well to just cut these pieces down to size. Just as a note, however, if you do decide to do something like this on your own, do make sure you wear adequate eye and respiratory protection when cutting this fiberglass board, because it's pretty nasty stuff. This board here is the main board for the preamp and power section, and as you can see, I used my template that I made out of 1/4 inch MDF to attach my component hole spacing template on top of, and then drilled out the holes on my drill press. And as you'll see in a moment, I also cut some separate smaller boards that I used for the rectifier and the adjustable bias circuit that you'll see, as I said, here momentarily. Here you can see the original chassis after pretty much everything has been removed. Basically, the only original parts I ended up using was the chassis itself, the power and output transformers, and the power switch. Pretty much everything else was rebuilt from scratch. That meant making and drilling out the boards from scratch, installing the eyelets that the through-hole components would be soldered to, very much like the original Fender style eyelet board hand-wired construction, only with more robust fiberglass epoxy boards. We also went with all new pots, a new jack for the input and the speaker. And looking close up at the chassis here, you can see a burn mark and some carbon from where the traces had burned up on the underside of the original board. Once I had all the eyelets installed, I began to populate the board and hook up all the lead wires going to the different components, the pots and the tube sockets and all that. And I attached the board to the chassis using brass standoffs. And now, after all the component boards were populated and soldered and all the leads hooked up, it was now time to go over every connection and make sure everything was hooked up correctly where it was supposed to be. It was now time for the before and after shot. So here's the original PCB on top of the chassis. And underneath we have the new Handwired Blues Jr. The preamp board, the tube socket board, the bias board. Oh, and I forgot to mention the filter capacitor board. I really wanted it built so that the next time somebody goes in to work on this amp or to service it and change the filter capacitors, they could easily just remove the filter capacitor board without having to undo all the rest of it. The other big problem with these amps in stock form is that they tend to over bias them from the factory, which is one of the reasons they get so hot. So I made a separate bias board where I could lay out the adjustable bias circuit. Also, hopefully you can see it here, but just to the left of the power switch is the rectifier board that I also mounted with standoffs just above the power transformer. And now, after double checking that everything was hooked up correctly, now it was time for the exciting part, to finally fire it up and see if I had power to the tubes. And after all that work and time and effort, this was a very rewarding sight to see here. Here we have the preamp tubes lighting up, meaning that the tube heater circuit was working. I should also mention here that one other mod I did was I did install the artificial center tap for the heater circuit. And that's done by taking a pair of 1/2 watt 100 ohm resistors connected to both sides of the heater filament secondary and attaching it to ground. All right, here we have it, finally completed, the Blues Jr. Handwired complete rebuild. One other little thing I forgot to mention as well is I did install an externally accessible fuse holder. So here we have the Blues Jr. again that I rebuilt from scratch. And one of the coolest mods in the rebuild that I did was add this adjustable bias circuit, which you normally don't have. So it fixes one of the major issues with the Blues Jr. amp in that they overbias it and it ends up cooking the board. And regardless of your Junior and regardless of how long it's been serving you great, it's a matter of time before it cooks or sets on fire. And that's what happened to this thing. Not only will it not cook the board now because we've got high quality ceramic tube sockets on the power tubes. But we can cool the bias down here. As you can see at idle, I've got the one of the EL84 power tubes at idle, just over 39 milliamps of current draw. And you can see here, if I go in and adjust this, it should drop it down. There we go. So that's way on the cool side. And bring it back here. And we turn it on, put some juice through it. Can't really play chords while holding the phone with one hand, but sounds killer. So yeah, this thing is exceedingly more robust and reliable. Got a real switchcraft jack, real pots that are not mounted to the PCB, so if the pots ever fail or are beyond cleaning, it's not a pain in the butt and we don't have to remove the entire board just to get the tubes out. Way better grounding. Also, not only are the filter caps much better, but when, not if, when years down the road these filter caps need to be changed, you also don't have to pull the entire board. You just pop these 4 screws out on this individual filter cap board, and no problem to change the filter caps. Makes a much easier and much less expensive job to change out the filter caps when they need to be. And of course, no problem swapping tubes out when they need to be swapped, but you can always cool down the bias, which really needs to be done on these Blues Juniors, especially to keep a reasonable amount of tube life on them. So being able to do that will give you much longer tube life on these EL84s that these Blues Juniors in stock form like to just chew up. And that's really great to have, because if you've purchased tubes anytime within the last couple years, you, like me and all the other guys who play tube amps that have to change their tubes, and realize that they are getting more and more expensive. But yeah, so I'm really excited about this. Completely rebuilt from scratch. Show you the here's the original junk board. You can see the pots here. If you had to change the pots, not only do you have to source these, but you have to pull this entire board out. You got to remove them from the PCB. Right here was another problem. See that cooked mark right there? No bueno. Let me focus in on that a little bit better. Yep. And somewhere else there was a lifted trace that I saw here. But yeah, and these stupid ribbon cables that go to the tube sockets, yeah, those are prone to breaking. So yeah, and the owner didn't use the solid state reverb circuit. So, and most people that play Blues Juniors don't use the reverb because it's garbage. It's just difficult to get a good reverb sound when you have such a small chassis, not a chassis, but a small small cabinet to put a small reverb tank in. It just doesn't sound very good. So, yep. Rather than that, no sense in putting the reverb circuit in if it's not going to be used. And what I also did here is right here. I'm doing some final testing on it, but that's the reverb pot, or that's where the reverb pot used to go, and that is now an adjustable negative feedback control. So that's a really cool mod to have. So yeah, all in all, much better. Here's the rectifier board. I put in a exterior accessible fuse holder, so much easier to get at the fuses. What else did we do? Much better switchcraft speaker jack. Put in artificial center tap for the heater circuit, so if there's ever a short or something in the heater supply, those little resistors will act kind of like fuses, and they will burn up and they'll protect the output transformer and the tubes. So we got that. Much more robust voltage dropping resistors there, along with the filter caps. Beautiful F&T filter caps, arguably the best on the market. And yeah, a real toggle switch for the fat switch there. Much cleaner, much quieter, way better grounding scheme. Yeah. This thing will be a tank. No longer will it run super hot and cook tubes. And most importantly, when it needs to be serviced, if not by myself, the next tech will be pleasantly surprised when he opens it up and sees all this beautiful goodness in here now. Sounds way better too. So yeah, pretty proud of this one. Still used the LED indicator light and the switch, and of course the power transformer and the output transformer. But other than that, the jack, the pots, fat switch, rectifier, filter cap board, adjustable bias board, a preamp board, all hand wired the right way. Nice solder joints, easily accessible components that aren't crowded together like on the other board, which does make a difference in the noise floor. So yeah. Is it worth it to do this to a Blues Jr? Cost-wise, absolutely not. But the owner of this amp is a longtime good buddy and client of mine, loyal client, faithfully refers clients to me and has for years. And I've already done work on this amp to fit it into a custom 210 speaker cabinet that he used. So with all the work that he's done with this, and you know, everything that's been done to the cabinet and the new speakers that he ordered, I just looked at the original state of the amp, and I didn't feel confident, even if I fixed it in its current original state, that it would be still reliable. So this turned out to be really a labor of love, but it was a neat project. It was head scratching at times and challenging, but rewarding, and I very much enjoyed rebuilding it. And yeah, it was worth it. So there's no way I could charge all the time that I put into it, but as I said, it really was a rewarding project. So I hope he loves it. I hope it sounds even better than he remembered, and I hope it serves him reliably for years to come.